Hello and a very big welcome to you, or welcome back if you're continuing your viewing to this Pluralsight video. My name is Andrew Mallett and I'm here as your instructor to help guide you through the module Adjusting Storage Device Access. And if you can understand what that is, then you're probably a better person than I am. The actual name we're using for this module comes from the objective that we're aiming to cover. For the LPI Level 2 exam, the 117-201, we're looking at Objective 204.2, and we can see that's called then Adjusting Storage Device Access. Before we get on to our content, let's just take a look at our lab setup. So we're using a fresh build of CentOS 7 with our root file system being on SDA. We've got a second device, SDB, and we're going to use this then to share out via iSCSI. So that gives you at least an idea that we'll be looking at iSCSI. But if we want to know the rest of the menu that we're going to look at, let's take a look through the menu. We'll be looking at partition numbering. We'll be looking at how we can configure disk using SD-PALM and HD-PALM. We'll be looking at configuring the iSCSI target or the iSCSI server, as well as configuring the iSCSI client or the iSCSI initiator. To begin, we're going to take a look at partition numbering. When we look at our disks, the device names there might be /dev/SDA or /dev/HDA. Really, we probably won't see too much of the HDA terminology anymore. It really relates to the 2.4 kernel and where we differentiated between IDE drives and from SCSI drives. The SCSI drives would be SD and the IDE drives would be HD. But since the 2.6 kernel, pretty much all of our fixed drives are showing as SD devices. The device number itself then would A, B, C, D, E, etc., being the first disk, second disk, etc., just numbering with the letter of the alphabet. When we look at the numbers themselves rather than just the letters, we have major and minor numbers. Depending on whether we're using the older syntax for our IDE drives where we've got HD, or whether we're using the newer syntax where we're using SD, really determines the number of partitions that we can have, because we've got a limited set of numbers that we can use within our namespace. When we're using IDE emulation, we could only have 2 controllers and only 2 devices connected to each controller. So that would give us then the names HDA, HDB, HDC and HDD. So that would give us more numbers to deal with our partitions. When we're looking at our newer systems and the 2.6 or later kernel, where pretty much everything is with SCSI naming, then we can have SDA, SDB, SDC, SDD, but we can continue through E, F, G, H, etc. So this is reducing the numbers available to us for partitions. So to that end, on our later systems, we are going to be restricted to a maximum of 15 partitions. And that doesn't really matter whether we're using extended partitions within the master boot record or whether we're using the GPT partition table, which should potentially allow for up to 128 partitions. We're going to hit then a limit on this numbering. To be able to understand and see the numbering, we're going to have to use our lsblock command, but we should be able to get an insight into how these devices are numbered. So let's move across now to our CentOS system to take a look at lsblock and understanding our device numbering.